Okay, is this like a good distance from the microphone? Never actually used a microphone before.
You sound great.
Sweet. Okay, so I'm going to be doing the first of the presentations that we actually give in the halls. This one is Life of a Water Bottle. So we're going to be, of course, talking about the life cycle of a water bottle and also a little bit of information about plastics in general. Okay, so first up is a general overview of sustainability. Brandon just talked about this a lot, but the kind of short definitions that we would give during an actual presentation are as follows. So sustainability in general is the ability to continue a defined behavior indefinitely. More specifically, for environmental sustainability, the definition is the ability to maintain rates of renewable resource harvest, pollution creation, and non-renewable resource depletion that can be continued indefinitely. For economic, it's the ability to support a defined level of economic production indefinitely, and social sustainability is the ability of a social system, such as a country, to function at a defined level of social well-being indefinitely. Keyword being indefinitely. All right, so more specifically for this presentation, to start off with, how did plastics come to be in the first place? So this guy on the left, Alexander Parks, was the first person to invent the first person to create man-made plastic in 1856, now known as celluloid. It's called this because it is an organic material made from cellulose, which has been heated, molded, and then can retain its shape after being cooled. And the reason this was a big deal was because it cost less than rubber did. And then about 50 years later, Leo Hendrik Baekeland created a new type of plastic when he was trying to produce a synthetic varnish. So he found a formula for synthetic polymer that originates from coal tar. And the reason it was better than the plastic that Parks made is because it couldn't be melted after it was formed. So a more improved version of plastic. And then in World War I, it was used widely, partly because whenever times got hard, they could use it as a replacement for stuff like wood, glass, and metal. And then also because they found that petroleum was easier to process than coal. And then after World War II, it became more common in commercial society, or consumer society. And then after that, we got more types of plastic, including polyurethane, which is stuff like memory foam or sponges, polyester, which is types of clothing, tarps, and bottles, and then silicones, which is stuff like kitchen utensils. All right, so what is plastic exactly? So to make plastic, the very first step is we extract oil and natural gas from the environment, and then in refineries, they're bonded together to make molecules. So basically, plastic is a synthetic, man-made material made from organic monomers. And then also recently, there's actually a way to make like plastic polymers that aren't oil and gas called bioplastics. So it still has some problems right now, but it doesn't require the use of fossil fuels. Okay, and then we're going to watch this video about the life cycle of a water bottle. Oh, all done?
This is the story of 3 plastic bottles, empty and discarded. Their journeys are about to diverge, with outcomes that impact nothing less than the fate of the planet. But they weren't always this way. To understand where these bottles end up, we must first explore their origins. The heroes of our story were conceived in this oil refinery. The plastic in their bodies was formed by chemically bonding oil and gas molecules together to make monomers. In turn, these monomers were bonded into long polymer chains to make plastic in the form of millions millions of pellets. Those were melted at manufacturing plants and reformed in molds to create the resilient material that makes up the triplets' bodies. Machines filled the bottles with sweet, bubbly liquid, and they were then wrapped, shipped, bought, opened, consumed, and unceremoniously discarded. And now here they lie, poised at the edge of the unknown. Bottle 1, like hundreds of millions of tons of its plastic brethren, ends up in a landfill. This huge dump expands each day as more trash comes in and continues to take up space. As plastics sit there being compressed amongst layers of other junk, rainwater flows through the waste and absorbs the water-soluble compounds it contains, and some of those are highly toxic. Together, they create a harmful stew called leachate, which can move into groundwater, soil, and streams, poisoning ecosystems and harming wildlife. It can take bottle 1 an agonizing 1,000 years to decompose. Bottle 2's journey is stranger, but unfortunately no happier. He floats on a trickle that reaches a stream that flows into a river, and a river that reaches the ocean. After months lost at sea, he's slowly drawn into a massive vortex where trash accumulates, a place known as the Great Pacific Garbage Patch. Here, the ocean's currents have trapped millions of pieces of plastic debris. This is one of 5 plastic-filled gyres in the world's seas, places where the pollutants turn the water into a cloudy plastic soup. Some animals, like seabirds, get entangled in the mess. They and others mistake the brightly colored plastic bits for food. Plastic makes them feel full when they're not, so they starve to death and pass the toxins from the plastic up the food chain. For example, it's eaten by lanternfish. The lanternfish are eaten by squid. The squid are eaten by tuna. And the tuna are eaten by us. And most plastics don't biodegrade, which means they're destined to break down into smaller and smaller pieces called microplastics, which might rotate in the sea eternally. But Bottle 3 is spared the cruel purgatories of his brothers. A truck brings him to a plant where he and his companions are squeezed flat and compressed into a block. Okay, this sounds pretty bad too, but hang in there, it gets better. The blocks are shredded into tiny pieces, which are washed and melted so they become the raw materials that can be used again. As if by magic, Bottle 3 is now ready to be reborn as something completely new. For this bit of plastic with such humble origins, suddenly, the sky is the limit.
Okay, so the material that a lot of plastic water bottles are made out of is polyethylene terephthalate. You're always laughing. Sorry if I pronounced that incorrectly. Also known as PET. It was originally created mainly for textiles, but can also be used in packaging. And it is the principal plastic in water bottles, so flexible and shatterproof. So going on. Here's another video. So this one's about how water bottles are actually made. Oh, sorry.
This will be our future. Unless...
Whether you're buying apple juice or peanut butter, you've probably noticed that fewer products come in glass containers these days. Plastic packaging is becoming more common. Plastic bottles and jars are lighter to carry and leave no shards of glass to clean up if you drop your grocery bag. Many transparent bottles and jars are made from a type of plastic called polyethylene terephthalate, or PET. An automated mixer combines PET pellets with flakes of recycled PET. Reprocessed plastic loses some of its physical properties, so the recycled content can exceed 10%. The PET drops from the mixer into a plastic injection machine that heats it to a piping 600 degrees Fahrenheit. The dry raw material melts into thick and gooey liquid plastic. The machine then shoots it at high pressure into a mold. This plastic injection molding process casts pieces of plastic called preforms, starter shapes that subsequent machines will transform into bottles or jars. The molded preforms harden almost instantly, thanks to a built-in cooling system. These preforms are now on their way to becoming single-serving juice bottles. This is another plastic injection molding machine. It uses the same method to make preforms for a different model, 1.5 to 2 liter bottles. The preform's next stop is a machine called a reheat stretch blow molder. In a matter of seconds, it heats each preform just enough to make the plastic malleable, then inserts a rod to stretch the preform lengthwise, while at the same time blowing in air at extremely high pressure. This forces the preform into a bottle-shaped mold. Cold water circulates within the mold to cool and set the plastic almost instantly. This lightning-fast machine churns out 10,600 bottles per hour. No wonder we've had to show it to you in slow motion. A conveyor belt transports the finished bottles to the packaging area. Before blow molding, the preforms for certain models first pass through an oven.
Okay, so just to talk a little more specifically about part of what happened in the video. So there's two main types of molding that happens whenever you're creating a water bottle. The first of which is injection molding. So they heat the plastic up so it becomes malleable, as they said, and then it's pressed into a mold for the bottle that they want to create. And then the other kind is blow molding, which is very similar. It still has the liquefied plastic, but that's when they're using air to like blow it out so it fits into the mold. And it's really easy to use for bottles because they're hollow. So when it blows out the air, it just goes out into the mold. Okay, so after the bottles are made, now they have to be packaged. So this is where they're disinfected. You put in whatever's in the bottle. So if it's water, it could be soda. I think you said peanut butter, I guess. And then it's branded and labeled by the company, so they put all the labels on the outside, and then ready to get transported out to stores. And all of this is done by machines as well. So they'll also have like a conveyor belt that goes around and puts all the labels on and stuff like that. So after it's packaged, it goes out to the people, and then the people use the bottle, and then after that, we get to the recycling. All right, so there's also two types of recycling for plastic water bottles. The first is mechanical recycling. So this is where the bottle's actually shredded into small pieces, like in the video. And then they're washed, sterilized, and then sold back to the manufacturing companies who can use them in new products. So, yeah, and then remember that only like a small bit of recycled material can be used in a new product because it loses some of the quality that it had. And then the second example is feedstock recycling, which is also shredded into small pieces and then subjected to really high heats so that the polymers break down. And then a process called pyrolysis is used to generate heat, CO2, and H2O. And this is also used by the manufacturing companies. And then these are just some facts about on the global scale. So approximately half of all plastic water bottles are recycled. So that's good in the sense that half are recycled. But that also means half are not recycled. And I forgot what I was laughing. Okay, so throwaway plastic bottles are the most common type of plastic packaging found washed up on the world's shorelines, and the second most common found on the top of the ocean's surface. And then more about how much plastic is produced. So 2 million tons of plastic bottles every year just by 5 companies. And then top 6 soft drink companies use a combined average of just 66% recycled PET globally. Okay. And then, more importantly, what can you do? So pretty much the easiest option is get a bottle that is not throwaway plastic. So there's several different options for that. So you can get the plastic ones that are reusable. Like, I think you have one right there, maybe? Oh, I can't see from here. Over there, there's one. So they're lightweight, they're durable, but they can also slowly degrade over time. So sometimes it's suggested that you replace them after, I think it's either a year. Is about every year you should replace a reusable plastic water bottle. And then another is metal. So it's a little more difficult to clean and might taste a little more metallic, but I think they last longer, so you don't have to replace them. And then glass. They're easy to clean, lining free, but you also don't want to drop them if they're really fragile. And then if you have to use a water bottle, just make sure you recycle it. And also watch it out for in the hallways, because even here, like, I still see people throw like plastic water bottles in the trash can. Like, our dorm has plastic water bottles in the trash can every single time I go out. So even though it seems like really obvious, you know, recycled plastic water bottles, people still throw them in the trash, and it's one of the easiest things. So keep an eye out for that, and make sure people know recycle water bottles, or use one that you don't have to throw away. Here are the sources for the presentation, and that's it for this one.
With this presentation, I will mention that the percentages of recycled plastic used in products were relatively low, and that's because it's talking about plastic water bottles, and food-grade plastic is of the highest quality, so it's going to require less recycled plastic because quality degrades through recycling. So lower quality plastic items would be able to have higher percentages of recycled material.
Good. I guess, are there any other questions about this one? And just so you know, if you are on the education committee and are going to go out in the hall and present stuff like this, it comes with a script. So you don't have to memorize every single fact. All right.